All right, we are recording. So here's a quick agenda for today. We're kind of running slightly late, and I think we can catch up. So we'll basically do a quick intro of Henry and then dive into the tech talk. Then we reserve the last few minutes for a Q&A. So here's a bit about Henry. He is a Google developer expert in machine learning, and he's currently working as a data scientist and pursuing his PhD at Texas A&M University. He is an expert at machine learning and deep learning, and he's worked with stuff around geophysics and remote sensing. I think his one of his main focus areas is agriculture and how you can apply data science and machine learning to agriculture. Henry, would you like to add something to that?
No, I think that the introduction was perfectly fine. Yeah, thank you so much.
Cool. So yeah, before we begin, here's a plug on GDG Chapel Hill. So we're a group of developers here in the town of Chapel Hill, and we do these meetups usually on most weekends, usually once a month. And so it's great to have you here. I think this time we have a huge cohort of people joining for this event from all over the US and maybe the world. We received a lot of requests for and questions for what Henry could cover for this talk on generative AI. There's been a lot of buzz around this topic. So I think we've tried our best to cover a lot of points. And we're going to split this talk, in fact, into two parts. So Henry can talk more about that, but just a bit about our chapter here. And yeah, here's a bit about me. So I'm a software engineer in Raleigh area. So if you are around, hit me up. And yeah, eager to meet people around town here. I've recently moved from Chapel Hill to Raleigh. So yeah. And if you want to introduce yourself, feel free to use the chat. Always you can drop your LinkedIn and talk about yourself here. And let's just get started. Here's a bit about the platform you're on. You can use the general tab or Q&A button on the right side to ask questions, and we'll try to respond to them either in the chat or we can take them up in the last Q&A session. All right, over to you, Henry.
I think you have to turn on the Q&A. I think it's not turned on before we go over.
I think I started the Q&A. Can somebody confirm? You can see.
I see it.
Yeah, yes, I can see it.
Thank you.
Okay, so yes, probably gonna. Okay, thank you so much, for inviting me. So it's thanks for the opportunity to be here, and I'm really excited about this talk because generative AI is like really hot topic these days. A lot of people is talking about that. We recently get a lot of really cool announcement in Google I/O, and it was actually like, really hard for me trying to kind of make this presentation because there is so much topics to cover that are like around this concept of generative AI. But I will try to do my best. This is why actually we decide to split the talk in two parts. Today we're gonna focus more in kind of the concepts and learn how like kind of like what is behind of this generative AI age and all the stuff that is going on right now. Because at this point, people tends to believe that generative AI is only ChatGPT and BART, but there is so much stuff around that concept. And I'm gonna try to cover these key terms so you guys can have a better understanding of what is this about. And we need to still figure it out when we're gonna do the other part of the talk, where we're gonna focus more in doing the demos. But this gonna be just basically from ground out to start like playing around with all of these tools that are available. But I'm pretty much gonna show today what is generative AI, the different application, the different concepts. So, like how deep learning have evolved in the last years, and how we right now like these large language models then seems to be kind of like the future a lot of people is talking about. This is basically what I'm gonna show today. So I'm gonna share my screen, and please let me know if you guys can see the presentation.
Yep, looks good.
Good. So in today's talk, this is the agenda. So probably there are some people here that doesn't have so much experience about machine learning. So that's means that I'm gonna try to provide like a very quick introduction about machine learning, to different concepts. I are not planning to go so deep into this because there are so much kind of online material and really good courses that you guys can go and kind of going in deep in all of these concepts. But I think that I feel like I was appropriate try to kind of like start with this because most of these technologies are being adapted now for software developers and for and even for other people that works in other kind of contexts or in other areas. So that's mean that I feel like it's good to like provide an introduction to what is machine learning. So then I'm gonna jump into the new goal, and I'm gonna discuss about different data generation techniques, and I'm gonna show like a demo, and I also going to share like a Jupyter notebook where like it's a collab. And you guys can after the presentation go and play around with the code, check the demos and everything. And then after that, I'm gonna talk about the generative AI revolution, and I'm going to discuss a little bit how we come from GANs, which is a kind of deep learning architecture, which in this case, this is the short term. This is the short term for generative adversarial network, which is a deep learning architecture focused on in generative generating like content, which is kind of like the one of the um, concept behind all of the generative AI stuff, and how we come from that to what we have today, which is the large language model. Like we're gonna talk a little bit about ChatGPT and BERT, but the objectives of this talk is not about like going and try to compare these technologies because there is so much information out there, and you guys can actually go and experiment by yourself and get a better idea about what is going on. So please let me know in the chat if you guys have any question. If probably you guys couldn't hear well or listen well, so please let me know. So then I'm gonna also talk about the generative AI race. When I'm gonna discuss about this fusion between Google DeepMind and Google Brain, and how they are working now in the new generation of large language models, and how OpenAI is kind of doing the same thing. So they got a partnership with Microsoft, and they are right now also pushing hard in trying to democratize all of these technologies for people use in a different context. In the next talk, we're gonna focus more in all the kind of announcements that were released in Google I/O, and also we're gonna show some cool demos. So this is basically the agenda for today. Okay. So something really important to mention here. So I won't focus on in the math behind of the algorithms or the models. This is gonna be more about trying to kind of uh, develop in you guys an intuition behind all of these kind of technologies, because um, I don't really like kind of like the puts math in my presentation, because some people just like trying to kind of get some understanding of these algorithms, these technologies, and this kind of stuff. And I feel that this probably for them it couldn't be friendly for start working and start using all of these technologies. So this gonna be focused more in the intuition. If you uh, gonna go more into the details and the math behind of how all of these models were implemented and how these models work under the hood, you guys can send me a message in LinkedIn, and I'm gonna be happy to provide all the reference and the papers that I kind of use for prepare this presentation, where they actually go in details into the map and they explain pretty details all of these kind of algorithms. So I'm gonna talk very quickly about my experience. So I'm working currently as a data scientist in Texas A&M Agri-Life Research, and I also a PhD candidate in the Department of Interdisciplinary Engineer, and I am also a Google developer as pre-machine learning, open source lover. I really like to develop tools for people uh, use all of these technologies and facilitate kind of like how they interact with them. So please go and check my GitHub, and you guys can have a good idea about some of the project that I have been working on. So my research has been mainly focusing in all of these technologies, specifically the intersection between remote sensing, data science, machine learning, and deep learning to help farmers and researchers to solve different problems, analyzing data and doing prediction and all of this kind of stuff in the context of agriculture. So it's kind of like a really cool way to apply all of this knowledge in for the human well-being. So my PhD topic is I am working right now using ground penetrating radar, and my goal is my 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 PhD is focusing on developing and implementing signal processing and machine learning algorithms to analyze that data and develop the software to. So the reason why I put this here is because if you guys have, if you guys want to discuss any of these topics, so please let me know, and I'm gonna be happy to learn from you guys and also like discuss all of this kind of stuff with you. My PhD research areas are signal processing, computer vision, machine learning, deep learning, and you guys can see that in the slides. So what I'm doing. We're gonna show pretty quickly some of the projects so you guys can have a better idea how I am using AI and all of these technologies in my work. So we are using, for instance, um, different kind of machine learning and deep learning techniques uh, to process point cloud data that we used to collect with different sensors. Here, this is a platform that we developed using Kinet. It was kind of like what we use by them, but right now there are more kind of sophisticated LiDAR sensors to collect 3D data. But we basically combine IoT with this LiDAR uh, and 3D sensors to collect information and try to extract some useful data through different pattern recognition techniques for farmers and researchers to use. And this is my current project right now. We are using a technology that is called ground penetrating radar, which is the same technology that NASA is using in the rover Perseverance in March to do like a soil exploration. But we are doing kind of the same thing to we are kind of try to adapt the same technology to see if we can monitoring how the roots are growing, like for instance potato, cassava, and we are using a lot of signal processing and machine learning algorithms to do that. So a lot of like object detection, computer vision stuff for plant diseases and crop disease classification. You guys can check some of the publication that I have in Google Scholar and have a better idea how we are using all of these technologies for facilitate and provide information to farmers and monitoring how the crops are growing. So and somehow you can actually see how you guys can generate impact with all the work that you are doing and with your skills. So this could be like a good thing to do. So and this paper that we are we actually have the recently like published the draft. This is gonna be available very soon for the public. So this is a paper where we actually use generative AI to generate images of rashes in banana, which is in this case is one part of the plant that the only way that we have to collect data from that particular uh, part of the plant is in a destructive way. So we actually need to kind of like cut off the plant to be able to collect information about this particular disease. So that's mean that we come with an approach to use generative AI to instead to kind of like collect data in a destructive way. So we can take the advantage of the generative adversarial networks and to generate new images or to generate synthetic images. So I just pretty much showing you the different application, all of this stuff that is going on right now. So this is another study that we use, where we use also like AI. So this is one of we use ground penetrating radar for imaging the citadel of Alcatraz for identify different spectral fixtures and different kind of in the diagrams, and we also are applying all of these kind of techniques. So this is one of the open source projects that you guys can check in my GitHub. And then now I'm gonna jump into the topic of today. So I'm gonna first start with a review, like quick review about machine learning. And I'm gonna first give you a definition of what is machine learning. So if we want to define machine learning, I'm gonna provide two different ways to do. So you guys gonna find a lot of definition in internet. So this is two of them that I try to kind of, well, I basically try to take some information and come with these two definitions. So from a general perspective, we can talk about machine learning as a subfield of artificial intelligence that focuses on developing algorithms and models that in this case enable computer to learn and make prediction or decision without very explicit program for that. And in the way how the computer does this task is by training a machine learning algorithms to learn patterns from the distribution of the training data, and with the goal to identify relationships between the samples that I provide, and then based on that knowledge, my algorithms or my trained model could do predictions in new data. So this is pretty much from a very kind of superficial definitions. If we want to do, if we want to be more specific, or more kind of like have like a more science-oriented definition. So machine learning consists of fit a mathematical or a statistical model using historical information. In this case, to infer or predict the value of a variable. And these output variables could be either continuous or discrete. And this actually is pretty important because this is what defines what kind of problem we are trying to solve. When my model predict a continuous variable, so that's mean that we are trying to solve a regression problem. But when my model is trying to predict a discrete variable, so in this case that we are trying to do is a classification problem. So this is pretty much the two difference between classification and regression. But there are different ways that those algorithms learn. And it's really important to mention that predictive modeling is just like a small part of like what actually means to do data science. Data science involves not only machine learning and predictive modeling, but also a lot of stuff related with data visualization, data cleaning, feature engineering. So, so this is why to become a good data scientist, it's really important to learn and not focus only to try to memorize how these algorithms works, but also gain some experience of how we can get or how we can identify patterns in the data using different techniques, not only machine learning, but uh, could be, for instance, visualization. In fact, a lot of data science problems could be solved just using statistics or like even just using data visualizations. That's mean that these are like a really important components of the data science life cycle. Yeah, this is a really good point. These two definitions kind of describe generative model. Yeah, this is true because we are just still doing the introduction to machine learning. We're gonna jump into the generative AI models, and we're gonna talk more about that. This is why um, I know that probably you guys are like advanced users, or you already know all of this information, but probably there are some users that they don't really have so much experience about machine learning. This is what I'm trying to provide some introduction or some background about what machine learning is. Okay. Okay. Let me see if I can do full screen my. So how I can do this full screen. Yeah, let me please try to do this like a full screen.
Yeah, I think this is much better. Can you try just going into the presenter view now? I think it might
Uh,
just work.
Okay, so
Yeah,
now you guys
much
can.
better.
Okay,
Thank
so sorry about that. Okay, yeah. So again, so
It's weird. I can only hear that person who just spoke, but I can't hear the presenter.
okay, you guys cannot hear me.
I hear everybody.
Yeah, I can hear you.
you.
You can refresh your page, and that will fix it. Oh, but he cannot.
Okay, can you guys hear me now? Good.
Yeah, Henry, we can hear you, but I think one of the people can't hear you. I think they need to refresh their page so that they can hear you. You're all set.
Okay, cool. Okay. So when we were actually discussing about how machine learning are able to do prediction, and based on the kind of variable that I am attempting to predict using this model, so this actually defines the nature of the kind of problem that I am trying to solve. So we discussed that if the output variable that I am trying to predict is continuous, so that means that I am dealing with a regression problem. But if the variable that I'm trying to predict is discrete, so that means that we are talking about a classification problem. But these algorithms have different ways to learn. And here there are like pretty much the three more common ways how these algorithms learn, but there are different other kind of ways to do so. So this is not only the three mechanisms that these models or these algorithms use to learn, you know. We're gonna pretty quickly to show or discuss about them. So when we're gonna try to train a model to identify, uh, imagine that I have like a data set and I just want to try to find patterns that allow me to create groups or cluster of data that somehow have similar uh, statistical properties or different kind of features in common. So we can use unsupervised learning to identify clusters of data, or also I can do the same way to train models to perform, for instance, like the dimensionality reduction or this kind of stuff. So in unsupervised learning, the machine learning approach is where the model is learn patterns and structures in unlabeled data by revealing the hidden relationship between the data points. So just think about my data set. My data set is just a bunch of different observations that I collect in the real life. And we can treat each of those observations like a data points. And I can use these kind of algorithms to identify relationship between and create clusters of data. This is how actually like we use unsupervised learning to do so. And there are different algorithms for clustering. So in this case, we don't really have like any hypothesis. We just have data, and we somehow want to come with these clusters or these ways to group my data based on that. But there are other kind of problems where, for instance, where I have a data set with samples that are already kind of labeled. So that means that think about like you want to train a model to classify dogs and cats. So you can provide the model with these images and the respective label. And for that, we can use supervised learning. So as the name indicates, so basically we provide training samples, which is in this case a pairs of the inputs and the expected output, and the model gonna try to learn from this labeled data to make prediction or in a new unseen data. And in this case, we already have like a hypothesis because we already know that we want to do something with that model. So we want to predict that this is a cat or this is a dog, and we just collect a bunch of different samples and we provide that to the model. Another way these algorithms can learn is using reinforcement learning. And this is the way kind of more similar to how humans actually learn, because it's based on like learn from mistakes. So in this case, we have like an environment and we want to train a artificial intelligent agent to perform a specific task in that environment. And in the way that we can do that is we can we can actually push the agent to kind of, by interacting with the environment and receiving a feedback about the action that this agent performs into that. So we can actually learn to perform like a specific task. So this is pretty common in tasks such as autonomous driving or this kind of stuff. Also for like solve different optimization problems, for instance, like a stock price, a prediction or this kind of stuff where it just kind of like a running a simulation, and then my agent gonna start like performing the same tasks in every iteration of my model, and every time the environment going to provide feedback to the agent and going to let him know if the task is okay or is not okay, and then based on that, the the agents gonna be more smarter and smarter. Okay, so this is pretty much the three basic way how these algorithms learn. So this is kind of like some animation where you guys can have a better understanding or idea how these algorithms work. For classification, we have a distribution of samples, and then we try to classify to what kind of class those samples belong to. Or we also have the clustering where we have like a bunch of different samples and we want to find kind of similar properties between them. And we also have reinforcement learning where we have like the artificial intelligent agent that is performing like a specific task multiple times until like is able to figure it out how to do that based on the information that the environment provides. So generally you have like a different sensor or different ways to provide feedback to the agents. So for instance, for like the autonomous driving, you have like the camera, you have the lidar, you have different kind of sensors connected to the car, and then based on the information that all of those sensors collect, the agent is able to improve in the way how the task is performed. So this is like two examples of regression and classification. Regression, imagine that you want to predict like the stock price. You collect a lot of information about the historic data of different companies, and you can train a regression machine learning algorithm to do so. Or the same for classification. So this is pretty much the machine learning equation, and this applied to different kind of type of algorithms. So we have data, we have an algorithms, we take that algorithms and train that algorithms of the data that we provide, and then the result is gonna be the model. So we tend sometimes to get confused with the difference between what is an algorithm and what is the model. The algorithm is just the procedure that we're gonna use to train the model, but the model is the algorithms and the set of parameters that I use, and those parameters that the algorithm learn to do the predictions. So this is very important to have clear the difference between each of them. And this is pretty much how is the pipeline. You could feed your model with structured or non-structured data, and based on that, you define if you want to use like a traditional machine learning algorithms that are based on feature engineering. So that means that you already have the features, and then you provide them to the algorithms, and the algorithm is able to learn from them and do predictions. But in some scenarios, when you have like an images or audio or video or this kind of non-structured data, we generally use deep learning, because the good thing about the deep learning is that we're gonna see the difference between these traditional algorithms and deep learning is that deep learning architectures, they have a set of layers focus on extract the features before to actually jump into do the classification. So this is how actually it works. So let's to make an example. So imagine that I need to train a machine learning algorithms. I get hired to create like a mobile application or something to classify based on like a picture that what kind of flower is. For instance, if I imagine that this is my image and I want to predict this image is the image of like a Iris serosa or Iris versicolor or Iris virginica. So then if we're gonna use like a traditional machine learning algorithms, so we need to first extract the features and then we create this data metrics with all of the observation and the features, and then we train the model. So then in this case, using traditional approach, we handcraft the feature extraction, and in this case, we are using image processing. So then we take the image, we apply some pre-processing, then we segment just these parts of the image that I'm gonna focus on, and then also using image processing, I'm gonna try to create this feature matrix, and I use that feature matrix to train the algorithms. But the key point here is that first I need to come with this feature matrix before to jump into training the algorithms. So this is the feature engineering approach, which is traditional machine learning algorithms. But what about if I want to solve the same problem by using deep learning? So the cool thing about deep learning architecture is that I can use, for instance, convolutional neural networks, and this kind of architecture, they are split into parts. The first set of layers are focused specifically in trying to extract features from the images, and then the top layers, the top end layers are focusing in trying to take those features and perform the classification. So that means that the model going to learn not only to classify the different images, but also going to learn what kind of features somehow maximize the probability of predict if like this case, like the flower is versicolor or serosa or a different kind of flowers. Okay. So then, in summary, the difference between machine learning and deep learning is traditional machine learning algorithms. You're required to have the features. So that means that you come with an approach to handcraft the features and create the data matrix. In deep learning architecture, generally you don't need to do so because this model already have these feature extractions layers. But the only difference is like deep learning require more data to be able to do so. Okay, so and also there are two different approaches to learn machine learning, or like to focus on machine learning. So a lot of people ask me about, I need to be a PhD, or I need to be a mathematician or like a statistician to learn machine learning, and you don't really need to have any background in well, you need to have some background, but you don't need to be a mathematician or like be an expert in all of this stuff. So because we have pretty much two different approaches, we have machine learning practitioners and machine learning research. Machine learning practitioners, generally what we need to learn is how to deal with data, how to create the scripts and use different machine learning frameworks, and trying to develop some intuition behind of the different algorithms. In research, you are focused more in read papers, trying to compare different techniques, translate math into code, and all of this kind of stuff. And according to your experience, you also pick the appropriate tools. So we have a lot of high-level tools. For instance, if you don't really have so much experience coding, you can just go and use the APIs or all of these kind of UI tools that Google Cloud, Azure, IBM, AW offer to kind of interact with these algorithms. So that means that you don't need to take care so much about how these algorithms are implemented and what is happening in the backend. Instead, you just try to connect your application with these APIs, and you are able to use these models. But if you want to really go more in deep and you want to try to kind of learn how to implement these algorithms from scratch, there is a bunch of different tools to do so, like a scikit-learn, which is like a Python library that offers like a bunch of different machine learning algorithms. Or you can just go and use TensorFlow or Python to create your own custom deep learning models. Or for like the, training optimization and this kind of stuff, you can also use tools like Dask, Numba, and all of these things. And what actually happens under the hood on how these models actually understand data? Because so like what we do is we have like a bunch of data that could be structured or non-structured, and we're just gonna try to feed that data into a machine learning model to solve like a specific task. But machine learning algorithms, they don't really understand about they don't really understand like audio files or GPG images or PNG files. They only understand numbers. And this is why what actually happened under the hood or how these algorithms works is like we at the end, or these algorithms at the end, transfer the data into a vector representation. So we need to transfer our data that could be like images, JSON files, text, video, or even like a structured data like a Excel file or like just a table in a database. We need to transfer that data into a feature vector. And then once we have this vector, we can project that into the feature space. And this is where those actually, those algorithms actually try to find a way to classify or identify kind of like different relationships between these points in the space. And it doesn't necessarily need to be like a 3D space, because the number of dimension of my feature space is going to depend of how many features I have in my data set. So in my data set, I have like a 2,000 features. So that means that my feature space is going to be 2,000 features. We just are familiar. We generally like when we talk about vectors, we only think about 2D or 3D because this is the only number of dimensions that we can actually visualize. But we can actually have feature space of n different dimensions. So then at the end, what actually happens is that we take the data, we transfer that data into vectors, and then when we have this data in a vector representation, we project that into the feature space, and we pick an algorithms that perform like a declassification or the regression or whatever we are trying to do. And in general, this is what's happening in the background. And this is the machine learning pipeline. So we have a problem. So we just have like a team to solve that. And according to the role that every person has into the team, well, that person perform like a specific task. So we come from an idea, and then we perform a lot of processing in the data set that we collect, and then we applied different techniques to do feature engineering or extract feature from our data. Then we train our model, we perform the evaluation, and then at the end, we decide how we're gonna deploy that model for users to start kind of adding value to our machine learning stuff. This is pretty much about machine learning. And right now, we're gonna jump into the new goal on different data generation techniques and why learn about all of this generative AI is really important, and why this right now is like a boon, and everyone wants to learn about how to use these technologies and how they can somehow integrate all of these tools into the daily workflow. And the reason why we need to learn about data is because the data is the new goal and it's the fuel of the machine learning models. So without data, we cannot do basically anything. All of these probabilistic models, all of these large language models, they are actually were trained because they basically took a lot of internet data or data from GitHub or all of this kind of stuff. And so data is really, really important. So, but since what is data? Data could be defined as a collection of facts information or statistics that are often represented in a numerical or a digital form. And this data can be stored in different ways. It can be like a database, like a file, there are like a bunch of different techniques to do so. And this data could be structured or non-structured. But, well, this actually here a definition between a structured and unstructured data. A structured data refers to the data that is organized in a format in a specific way, typically within a fixed schema. And unstructured data is just raw data that is not organized in a specific way and doesn't fit into any schema or anything like that. So this is the kind of data that we use to train these huge models. This like a huge large language models, or this deep learning model, or this machine learning model, or so this is why all of these models require so much time training, because they can actually handle a bunch of different data. So how this data is generated? The structured data is generated through like an intentional effort to organize and format the data in a specific way. So that means that we have like a team, and that team gonna focus specifically on that data and organize and format that data in a way that the machine learning, the statistical model, or this data can fit without any problem. But unstructured data is this kind of data that is generated through natural and unorganized means. That means that this is the data that we generate with our phones, taking pictures, or the data that we use in GitHub, they generate in GitHub every time that we make a pull request, or we can do like a commit, or we can all of this data that we don't really have in mind any kind of idea to create a model or this kind of stuff. So an example of structured data could be just databases, Excel files, CSVs, or this kind of stuff. So unstructured data can be generated through social media, emails, audio, and video recording password, etc., etc. Okay. Now, let's talk about the age of generative AI. So right now, the boom is, or the explosion is like all of these kind of advanced techniques that has been kind of like show up in the last years to generate synthetic data. But what is actually, or how we can actually define synthetic data? Synthetic data is data that has been generated artificially that somehow mimics the statistical properties and structures of the real world data, or that data that we use for the training. Okay, so this is so like in order to these models work, so we just feed the model with the data, and then the model going to try to learn the distribution of that data to be able to do predictions, and those predictions, those outputs should have the very similar statistical properties, or they should like have like a come for like the same distribution of the training data. Okay. When is very useful to kind of like generate synthetic data? Synthetic data can be used in situation where real data is scarce. This is like very common situation in the real world. Sometimes, for instance, the example that I just mentioned when I saw the presentation. So for this specific banana disease, in order to collect data for that races, that part of the banana plant, we need to cut off the plant or destruct the plant, and we don't want to do so. So we can use these techniques to generate synthetic data. There are some scenarios also that we cannot even access to the data because it's sensitive. So that's our proprietary. So that means that we need to come and use these algorithms to do so. Okay. So please let me know if you guys have any question. And this data can also generate, but in a interactive way using different interface, which are those used by the language models. Like right now it's very common, this concept of prompting, or like prompt engineer, all of this kind of stuff. Because basically the reason why you need to learn how to talk with the model is because what we are trying to do when we write something in ChatGPT or in BART, is we are trying to guide the model to do exactly what we want to the model do for us. So this is why we need to kind of specify very clear and very details what we want. Any question until this point?
So I think Sudhanshu had a question about how can one get started with practicing and furthering their learning in this field. Um,
Yeah, so I'm gonna get into that point pretty soon. So I think that I'm still having some time. So I'm gonna get into that point. Right now I am pretty much explaining the concept, but at the end I'm gonna show the tooling. And in the tooling I basically gonna describe the different um, kind of libraries, packages, interfaces, API that you guys can use. And there are different levels. Like if you are like it's basically according to what you want to do. If you just want to integrate this solution into your application, you can just go and use the APIs that are already there, like the BAR API or the GPT API or this kind of stuff. But if you really want to go more in details, you can actually go and fine tuning some of the more like models, like a llama or. So I'm gonna just pretty much talk about them. So, but I really want you guys to understand why we generate data is really important in different contexts and which are the different techniques, because it's not only we tend to associate generative AI with ChatGPT and nothing else, but generative AI is a lot of stuff. It's not just ChatGPT. In fact, it's just like an interface to interact with these models, but on the background there is a lot of stuff going on. There is actually something that is called multimodal deep learning. These models are able to generate uh, uh, different data, and this is what we're going to discuss later. So the first way to generate synthetic data is through simulations, and the simulation is just basically try to model a real world scenario or phenomenon, and you generate data um, to train the model. Okay. For example, a simulation could be used to generate synthetic weather data based on historical patterns and a statistical distribution. This is pretty common. This is, for instance, what NASA does for like the Perseverance rover, this kind of stuff. They need to do tests. They need to do testing, and they need to uh, first check if the robot works in the right way and this kind of stuff. So that means that they have like a simulation environment, and in this simulation environment, they can perform a lot of experiments and generate data to train different models. And another concept that is very common these days is digital twins, which is another way to generate synthetic data. And digital twins is just basically try to create a virtual replica of a physical system or process that is created using data from sensors, machine, or other sources. And digital twins typically consist of three main components: the physical asset, the digital model, and the data that leads the two. The physical asset is, imagine that the robot. The digital model, in this case, is the 3D representation of that model in the virtual world. And we have like a bridge or like a way to link these two components to generate data and be able to create the synthetic data. We can also generate data using just statistics. We can just use different random sampling techniques, and there are here some of them, like simple random sampling, cluster sampling, based on some specific feature of the observation in my dataset, or systematic sampling, stratified random sampling. You just basically can use the sampling techniques according to what we need. And we can also use, and here we start talking about more going in the direction to discuss about like how these diffusion models works, how these generative models work, and in order to jump into this more sophisticated architecture that combine other concepts like transformers and attention mechanism and all of this stuff, it's really important uh, to set the boundaries here. That basically what actually started with this kind of revolution was the generative models. The generative models, which are also known as generative adversarial networks, So it involves training a machine learning algorithms to generate new data based on a patterns in existing data. I basically take a model, I feed that model with my data, and then the model going to try to learn the distribution of my training data. And once the models have some knowledge about the distribution of my training data, the model is able to generate new samples that should be similar to those what I have in my base knowledge that I use to train the model. Okay, and some kind of architecture that are focused on in generative AI are GANs, which is the most kind of basic architecture. When I have in this case two different networks, one is the generative network and the other is the discriminative network. So the generative network gonna start kind of um, random sampling or generating new and new images. Imagine that I want to create a generative model that is able to generate people faces. So that means that the generative network gonna start generating images, and then the discriminative network will be trained to identify if those images look similar to the sample that I have in my training dataset or looks fake. And based on that, this discriminative network just basically gonna try to kind of decide if this image looks like a similar to the distribution of the data that I have for training or not. And we also have like diffusion models where you basically have like a latent representation. A latent representation, it could be this kind of a random noise that I have here. We can think about like a latent representation or like a way to encode my data. So in the way how this algorithm actually work, you take your data. Imagine that I want to train a test to image model. So I need to train my model with. I need to take the text, but I need to take also the image, and I need to encode those. Uh, uh, in this case, the text and the image, and I need to transform this into a vector representation, which is the encode version of my data, and I can use that to generate new data from text or from images, for instance. So this is how diffusion models work. We're gonna check more details about how this architecture works later on, but in general, this is two of the most basics deep learning architecture focus in generative AI: GANs or generative adversarial network and diffusion models. One is trained by using this concept that is called like adversarial training, when I basically have one generating network that generate images, and I have this other network that is basically gonna figure it out if that image is real or fake. But I also have the diffusion models, which is kind of like another way to generate images from noise. And we're gonna discuss more about that, how we can do that. So the GANs just basically learn the distribution of the data to generate new samples, and diffusion models, they just try to generate data from different latent representation, and latent representation could be this one or this one or this one. And based on that, the algorithm going to try to learn how to generate new images based on that noise. So I really kind of like encourage you guys to go and check this video, because we don't have so much time right now, but you guys can go to Google Research YouTube channels and check these two image models, and you guys can have more information and more kind of background about how these algorithms works.
Hi, and welcome to Hidden Layers, where we'll show you how some of the advanced machine learning algorithms from Google Research work in a way that's...
Okay, and another way to generate data is by applying different data augmentation techniques. Now, the difference between using generative models to create new data and use data augmentation techniques based on geometry is that here we are not actually generating new data. We are actually using the data that we already have, and we are applying different geometric transformations by random rotation, translation, or scaling on the 16 images. And by doing that, we are somehow augmenting my data set. So one difference between, this is the main difference between use GANs or use diffusion models, which are probabilistic models to generate new data based on the distribution, and this one, which is basically take an image and apply different transformation and generate more samples. So this is pretty much like what I have to discuss about how to generate data. Now we're gonna talk more into the generative AI revolution from GANs to large language models. And I'm gonna talk about ChatGPT. This is gonna take probably like a few minutes, like 10 or 15 minutes more too. But I want to share with you guys this notebook. I'm gonna, it's not this one, but at the end of the presentation, I'm gonna share with you guys this notebook. And in this notebook, I basically prepared a demo of all of these ways that we have to generate data. Can you see my notebook? No, probably not, right? You guys cannot see my notebook, right? Okay,
yeah, we can.
Okay, so this is the notebook that I'm gonna share with you guys. And in this notebook, I explain what is data, what is unstructured and structured data, how that data is generated. I explain what simulation are and how, for instance, NVIDIA is using that for trained deep learning models focusing in autonomous driving. And I explain how to use Python packages, for instance, like SciPy, to create synthetic data based on simulation. So in this case, I try to simulate kind of cooking system in a restaurant. So that means that you can specify like the number of servers that is in the restaurant, what is the arrival states, and generally how much takes to provide the service, and how much time you want to run the simulation. And you can use SciPy to create that such an environment. So this is the code. You guys can see the documentation here. I also do some example about different random sampling methods using Python. So you guys can see here how to perform simple sampling, systematic sampling, stratify, cluster. So I also have that code there. And I also introduced the concept of generative adversarial networks and how the generator and the discriminator work, and how you can implement your own GAN, in this case, to generate images of using in this case the MNIST dataset, which is a dataset that had handwritten numbers from 0 to 9. Okay, so I download here. I create a generator. This is the architecture. So this is, for instance, like the image that the generator create without any training. As you can see, it's just noise. So that means that here the discriminator gonna say this doesn't look at all as one of the example in my training data. So try again. And in this process, by using an optimization algorithms, so in neural network space and optimization, so then you define what kind of loss function you're gonna use, and the loss function define what kind of optimization problem you have, and the loss function is a way to measure like how well the model is performing, and then the optimization algorithm is gonna figure it out to find what is the best solution, which in this case is called this concept is called converge. The conversion is basically the point in time where the algorithm finds the best solution. So as you can see, when I create the generator and I try to create a new sample from a latent representation, which is just random data, it doesn't lose like any number at all in my data set. But after the training, I do the training here. Here is the training step. So the discriminator, the generator gonna start like get better and better and better and better, and at the point that when generating new images, gonna lose like this. This is a really cool concept of trying to learn the distribution of your training data set to generate new samples. And this is pretty much the concept behind of one of the concepts or one of the uh, uh, behind of generative AI is, like I also explain here how to start working with diffusion models for that, because this architecture are a little more complex. I didn't come with a from scratch implementation, but you guys can go and check the Keras CV TensorFlow package, and then you can use the stable diffusion um, library, and you guys can say, hey, I want to generate an image from text, and I could put the description, a dog playing in soccer, and this is the images that the AI generates. This looks like a dog playing soccer, but this doesn't look like it looks like a cow. But so this, and I also like discuss different data augmentation techniques. So I'm gonna share with you guys this a notebook. They're gonna give you a more intuition about how these different concepts that we have discussed so far. Like another really important concept is how the data is presented to the model. What I tell you before, so you have your data, you convert or transfer your data into a vector representation, and then now you need to figure it out and find a way how you can identify relationship between those vectors in your feature space. And there are different ways to do so. Because they are projected in the feature space, they are like a point somewhere, like in 2D, 3D, or n dimensions. So I can actually apply this kind of metrics or these functions. There is also like a metrics space. In the metrics space, you define how you can uh, uh, find relationship between vectors, and you can apply different functions like the Euclidean distance between. Imagine that this is a dog and this is a cat. So you guys can see here the from scratch implementation, all of this stuff. You guys can play around with that and check how this works. Okay, so I'm gonna get back to the presentation. Okay, so now let's jump into large language model, ChatGPT, and all of this stuff. So what is generative AI? Generative AI is a type of artificial intelligence that can create new content such as text, images, and music. We already discussed some of the ways to do so. For instance, using diffusion models or using generative adversarial networks. And in the way how these algorithms work or these models work is like it does by learning from existing data and then using that data to generate new outputs. The results after training is a probabilistic model that is able to generate new data. So imagine that you have a data set and the model is going to try to identify the statistical properties of that distribution. And once you have defined the statistical properties of that distribution, you can generate a random sample from that distribution, and this is what actually generative AI does under the hood. So the artificially generated data is expected to have the same statistical properties and structures as the real world data. So that means that you guys couldn't expect to get to classify if this is a cow or this is not a cow if you train your model to detect dog and cats. These models are generally probabilistics. So that means that the prediction depends 100% on the data that used for training. So don't attempt to get good results if you try to pass some samples that doesn't have any kind of similar properties to the in terms of the distribution to the sample used in the training. Okay. So generative AI use cases. Generative AI is a helpful tool that can improve the workflow of many people. A lot of people right now is scary because AI is going to replace the job of programmers. We are really away, really far from that, and especially because these tools have a lot of hallucinations. Hallucination means that because these models are probabilistics, these models are really good to generating content, but we always need to check what this data is generating, what these models are generating, because those models are liars by nature. They're gonna just generate random data, and some result looks pretty good. Let's look like this is another person in the other side, but some of other results are really, really bad. And then this is why we need to have the we need to basically uh, be careful about when we kind of pretend that this kind of AI gonna do our job for us. Even when you are using this kind of tools to generate text, or if you are using this for kind of helping with your writing, don't trust 100% of this tool, because these tools just can generate random data. Like you can go and check and and or something that you can actually do is you can easily go and try to bias the model. You can actually, I don't know if you guys have noticed, but when you go to ChatGPT, you can easily make him say what you want to say. You can say, hey, why the chicken come first than the egg, and he's gonna try to go in the way that you mentioned, especially because these models are designed for for you guys kind of use prompting techniques to guide these models do for you. So you basically use the prompt to kind of guide the models what the models wants, or what kind of result wants to produce for you. Okay, so we are far, far, far from actually pretend that this AI going to replace programmers, or going to replace writers, or going to replace. Uh, so we are in the point that we can actually make fun with these tools and actually help to maximize our productivity. If I use ChatGPT a lot for like a lot of scripting, but always I check, because this the limited of these tools have some limitation. For instance, ChatGPT has been trained, I think, that with data up to 2020 or 21, I guess, and then so like sometimes this generate like a bunch of imports that some libraries that don't even exist. So that's mean that this is really important that you guys um, uh, improve the way that how we are kind of showing this technology to the world. This technology is not replacing humans at all. This is just like a bunch of uh, model generating contents that have a lot of hallucination, and we just need to be careful of what we are showing there. So those models are able to take input such as text, image, audio, video, and code, and generate new content. And these models can be used for language, for the note taking, gene sequencing, code development, is essay generation, in computer vision for video generation, 3D models, design, image generation, for auditory, for like a music generation and voice generation. Some of the cases could be, for instance, for visual content. We can use all of these kind of tools, these diffusion models, to improve or show our presentation. We can generate new images and all of this stuff. This is pretty cool. We can also generate audio, text, or we can take these tools for like code advisors, and then use for code generation or code compilation or book fixing. Okay, so what is the difference between this kind of model, generative AI models, and predictive machine learning models, like a classify or for regression? So imagine that for classification, I generally present my model with samples and labels, and then the model is going to try to learn the relationship between the data and label by using different statistical and mathematical approaches based on the algorithms. And this is how there is the equation. This is how mathematically how it could be represented. I just basically gonna try to predict y prime, and the prediction gonna be the result of take the algorithms, pass the data or the model, and pass the data and the labels. The result is gonna be a model that could be probabilistic or deterministic. Probabilistic, so if the model has some random sampling evolve into the way how they do the prediction. Deterministic is just, for instance, algorithms like a K neighborhood, where I just basically, to predict this is a dog or this is a cat, I compute the distance, the Euclidean distance between one point to each cluster, the cluster of the cats and the cluster of the dogs, and I take the decision based on the distance. So this is deterministic because always I'm gonna get the same result. So y could be a discrete variable, a continuous number, or it could be also a probabilistic distribution. So at the end, we have a probabilistic or deterministic model that can do prediction on unseen input data based on what we learn. And based on what the model learns from the provide label and data pair, the model attempts to predict the value of the output variable. In generative AI, it's different. So we just pass in structured data, and the generative algorithm is going to try to learn the underlying distribution properties of the training data by identifying patterns in the training data. So we just basically try to get a new example from a distribution of data. So we basically try to get a new example that have very similar or like approximately the same probability distribution on my training set. Okay. And at the end, what I have is a training model, which is probabilistic, and Y could be a natural language, image, or audio. So after learning the statistical properties of the training data distribution, the model generates a random sample from that distribution. We're going to call Y prime. Y prime is generated like the predicted value. And Y prime is expected to have the same statistical properties and a structure as Y. This is how this model works. Now, how this content AI guide content generation works. Like, you know what I mentioned, I have this prompt, I have this ChatGPT or bar, and I just write down something, and I somehow try to guide my model to generate the output that I want. You know, so how this works? So this generally involves two steps. The AI content generation involves advanced algorithms to generate AI to produce content that align with human instructions. So this process typically is performed in two steps. The first is extracting the intent information from the given instruction and generating content based on that identified intentions. You know, this is why the quality of the result that you're gonna get depends 100% in the way how you prompt or how do you write down the to ChatGPT or to bar. You know, so that's mean that the result is going to depend also how we interact with these tools. Okay. And what actually going to happen is they're gonna take the test, and this test gonna be in code in a vector representation. So that means that this test is converted into a vector or into a Latin space, and the model is trained to generate content from that Latin representation. And then this is how we can actually combine techniques such as GANs to generate images from text or generate text from images, you know? And right now, these models could be unimodal or multimodal. So unimodal means that the model receives instruction and generate content in the same modality. So for instance, you pass text and you're gonna get text. You pass audio and you're gonna get audio. This is unimodal. Or you're gonna get image and then you're gonna get as an output like an image. Which is the way how generative adversarial network generally works. You put like an image and then just generate another one. But we also have, but most of these large language models, like the model behind of ChatGPT or BART, are multimodals. So that means that they receive instruction and generate content in different modalities. For example, image to text. So I can pass this text, and this text, I can generate from that text an image that looks similar. And for that, basically what I do is I take the code, I take the text and I take the image and I transform that text into an encoding representation, which we can think this encoded representation like a vector of numbers. And I can actually concatenate those vectors and train a model to be able to generate images or from text or text from images or vice versa. Okay. So generative language models, generative language models learn about pattern in language through training data, and generative image models produce new images using techniques like diffusion model. You know, go pretty quickly because it's a lot of time now. And how do we get to this point? So I'm gonna check with you guys probably these slides, and you guys can see here how has been the evolution of the different architecture to get to this point of ChatGPT. Some of the milestones that actually speed up the development of these technologies were actually started by Google, because Google did a really good job with when they come with this new model, the new kind of transformers architecture that improving the way how the algorithms could be trained in huge data sets. And because right now, like this, somehow you can parallelize the way how these algorithms are trained, and somehow this could be a speed up the training process of this architecture. And this is why at this point we can train these algorithms with like a huge volume of data. This is the evolution of from NLP, like using long short-term memory or LSTMs, to the point that we are right now, where we have this large language model. So how we come from here to here is because right now we have more computational resources, we have more data, and we also have transformers, and we also have techniques such as diffusion model or GANs that can help to generate new content. So if you guys want to get more in details behind how these algorithms work under the hood, okay, this is a principle also used widely on Tesla training. Yeah, exactly. Yeah. So if you guys really want to get more into the details about the foundation behind a transformer, I encourage you guys to go and check this concept. These are the main ingredients of the artificial intelligence generate content. So GANs, diffusion models, is basically generate random samples from noise or from different latent representations. Large language model, which is the new generational model that we have right now, and reinforcement learning from human feedback that have somehow get with this approach to improve how these models could work, because right now these models are more dynamic because they are not static anymore. So that means that right now the model doesn't generate the prediction and that's it. No, we can actually provide feedback to the model, and this is because they basically integrate reinforcement learning into the pipeline to train models such as ChatGPT that allow these models to learn from the feedback that we provide to them. So that means that every time that ChatGPT make a mistake, we can actually provide feedback to the model and say, hey, this is not the right or the correct result. And this is because these models are on the top of reinforcement learning. Because we saw when we started the presentation that reinforcement learning is a way to learn from mistakes or from trial and error. So that means that models generate an output, and they expected the human provide an input for them, like a feedback, and say this is good or not. And in that way, they actually update the policy of these algorithms, and these algorithms can get better and better and better, And they have like a bunch of different ways to control that you cannot just start saying no, 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 no to everything, and they kind of like get messed up. So, and another concept is transformers. So I already have some definition here, but this is probably pretty much. I can share with you guys this concept, but pretty much it's just try to gain some intuition behind which are GANs, what are diffusion models, and which pretty much we have discussed some of the concepts, So autoencoding, for instance, so they could take an image and generate a latent representation from that, keeping the statistical properties of the input data. So that means that I can somehow I can use this kind of model, for instance, to do or perform data compression. If I want to compress a video, I can use autoencoders to generate a way to encode that video in a latent representation that has low dimensions than my original data. So this is how these algorithms work actually. You come from one representation to another representation. That means that you come from your data from one number of dimensions n to another number of dimensions. But what these algorithms wants to do is try to maximize try to keep that the variability in your data set keep similar. Okay. And generative adversarial networks, we already saw that they just we have two neural networks, the generator and the discriminator, and they are competing each other. One is generating images, and the other basically say this is a fake image or no. And the diffusion model, which is it's very similar to what autoencoder does, but instead to generate samples in one single shot, they do this iteratively from different latent representation. For noisy sample, less noisy, even less, and then they have more contextual information to generate images. Well, I'm gonna go pretty quickly because now this is a really good point. We are almost done. Sorry, I know that this is so much stuff, but this topic is huge. And if you guys want to know more about all of these models, you guys can go to, if I can share my screen really quickly here. This is really important too. Okay, so if you guys want to learn more about these models, you guys can go to Model Garden on Vertex AI in Google, and they have a bunch of different models and you to perform generate text, generate natural language processing, and all of this stuff. Or you can go to Hugging Face. Hugging Face also have like a bunch of different implementation for image classification, diffusion models, zero shot classification, text generation. So this is a good way to start. Also, they offer like a high level API to interact with these algorithms. So I don't really need to go and try to implement this model from scratch, and don't do it. You don't really need to do so. You can actually just fine tune this algorithm. Fine tune means I can use this model that are already pre-trained with some data, and I can adapt these models to with my data and do something else. And all of these algorithms, you're gonna find here the documentation to fine tune, for instance, image to text, and this is a bunch of different models. This is a lot. This is why I didn't kind of wanted to focus in one specific model here. But another place to go is LLM-SU, the democratizing ChatGPT, and you guys can see here all the different variation and that you can use, and you can actually train and get more information about the number of parameters of how those algorithms were trained and all of this stuff. Just remember that these models are multimodal. Multimodal means that these algorithms could generate code, text, images, and this kind of stuff. And this is another kind of link that LM-SU. You guys can also find some of the model here, some of the implementation. You guys can go to the link and get more information about the model and etc. Okay, so how to evaluate, how do you generally take the decision if this model is better than others? Well, this is a little more tricky because we are talking about like a multi-model algorithms. So that's mean the way that we actually like check if one model is better than the other is checking the quality of the outputs. So how much the model have this hallucinate? So how much fake data generate these models? Diversity is like how this model is able to generate variety of samples. This is really important. And response speed is another way also to, if you compare right now ChatGPT with BART, one of the good things about BART is like BART is pretty quickly to generate outputs, but it's still, because BART is still in development, so still like doing a lot of kind of hallucination. So that means that you just need to give in to BART some time. What are the challenges right now of generative AI, and why right now, like, what is like a huge research area? So a scale of compute infrastructure, this is really important. Like right now, something that I like about the way that Google is trying to approach this is like they are trying to come with like a very similar accuracy to those huge models such as GPT-4, but trying to reducing the number of parameters, because if the model has more parameters, this require more compute infrastructure, And we don't really are aware about that, but so much of the carbon that is in the atmosphere is because all of this kind of stuff that we are doing in the eye context. So this is why in Google Cloud you can see this kind of green leaf stuff that supposed to be more kind of like environmental friendly. So we have a lot of responsibility on this area. Sampling speed, lack of high quality data. Sampling speed is a really good point. So something I have noticed, I start noticing recently in ChatGPT is, I don't know what is going on, but right now I start getting kind of more slow generating the results. And sometimes actually just don't generate anything. Lack of high quality data, this is another thing, you know. And data licenses. Data licenses is another like huge problem, you know, like these models, well, they say that they train this model like with the right licenses, but we don't really know, you know. But this is another really challenge in generative AI because you cannot train these models in data that is not public or have some kind of. Now to end this presentation, I promise that I just 5 minutes more and I finish the generative AI race. Right now we are in this generative AI race. We got in the news that OpenAI partnership with Microsoft, and right now they are working pushing the GPT to kind of like get there. Right now they have also they already have like a commercial version of the product. Google recently get fusion with Google Brain and Google DeepMind, and they are working in this new generation of models. So this is what is the state of the art of the large language models. This is the state of the art. So we have a different interface or entry points. We have ChatGPT that we know that doesn't have internet connection. And we have Bard and Bing Chat that they actually have. So please don't keep comparing Bard with ChatGPT. That's it. ChatGPT doesn't have internet connection. Even if ChatGPT is probably right now more mature and he's generating better outputs, just remember that the base knowledge of ChatGPT is limited. The good thing about solutions like Bard or Bing Chat is that they can actually get information from the internet. And this is actually made the tools more powerful. Probably they are knowing the point that they can generate so much better results, but it's because probably this integration between be able to do good prediction and also to get information from the internet could take some time, you know? But I generally prefer to compare these tools, Bar Chat and Bing Chat, and don't just focus in one single tool. Just try to see which one works better for you. You know, sometimes for me, personally, I generate the same text or the same with the both, and I try to compare, and I basically take the text that has better quality. Sometimes it's Bard, sometimes it's ChatGPT, but I don't really like to get into this competition that is out there in everywhere where people is trying to rank this is better, this is better, this is better. This is just there, this is technology, and we just need to take advantage of that and use it. So this is the interface that we have right now, and then through that interface we communicate or we talk with the large language model. And the competition is in this point. The competition between this Microsoft and OpenAI and Google DeepMind is in who have the best foundation model. You know, like so we have GPT-4, but we also had Palm and we also have Lambda, and there are different foundation models. And these foundation models are multimodals and also are unimodals, and then can generate content that could be text, code, or image generation. So that's mean that generally they are multimodal. So this is how the interface looks like at this point. This is the famous ChatGPT. This is Bard, and this is Bing AI. So I'm gonna just go and check in the Google Research website this link when they provide more information about what is how PAL 2 was designed. The thing is, like at this point, we don't really have so much information about how this architecture works under the hood. That means like what is the design of or the architecture itself, because Palm, we have this report, pretty good written, when you can actually get some intuition about what this model does, and also ChatGPT, but you don't really have the detailed description about how they were implemented. So at this point, and it actually makes sense because like so try to implement this kind of model from scratch, or try to model this model for scratch. This could take like months. So that's mean that this is why Google Cloud and all of these kind of platforms, they are offering different tools to fine tune these algorithms. But fine tune means it's like try to use the algorithm that is already pre-trained and training further with your data. So that means that you can have your model adapted to your context. But it doesn't mean that we're gonna train that model from scratch. It's gonna take forever. So I think you to check these research bites when they talk about Pound 2, and you guys can get more information about how this model works. Now let's talk about ChatGPT. Well, the video is not showing up here, but they're gonna share also the video about like ChatGPT foundation. This is the model generation that they have right now, GPT-3 and GPT-4, and they have the different variation that is called like you can kind of Da Vinci and all of these kind of different models that you can specify. But this is pretty much because they are multimodal, and you're like trying to use different implementation for generate code, for generate tests, for generate images. I don't know why this is not showing up here, but they're gonna show them this. Other implementation that you guys can play around that doesn't have the same number of parameters, but they are more light and they can more kind of easy going to start playing around and understand how these models works. You can go and check Stanford Alpaca, Vicuna, or you can use Llama from it. Well, Llama, I don't think that actually you can fine tune Llama, but you can fine tune Alpaca, which is based on Llama. But you also have Vicuna, which is also based in Alpaca or in Llama. Well, the thing like these are more kind of easy to adapt models that you can try by yourself in your environments and test and train, and that's it. And this is how you get started. So right now, to play around with generative AI, you have different options. You can just keep doing what you are doing right now, which is explode and use ChatGPT, BART, and all of these tools in your daily work. But also you can explore further these technologies and check the APIs. Google released like a bunch of different APIs in the Google I/O, pretty cool ones. And ChatGPT also already have embeddings, have text to speech, speech to text. All of these APIs are there like a really good performance. So you guys can go and check it out. Just this is another way to interact with this technology with generative AI through APIs. But if you want to kind of get more into the from scratch implementation, or you want to kind of get more into the code or this kind of stuff, you can use Hugging Face, LangChain. LangChain provide like a high-level API to chain different large language models. So that means that you can combine multiple large language models, and you can create like a chain on models, and you can use this chain of model to do predictions. And they provide like a Python API to interact with them. That means that you can have like a model 1 and model 2, and based on that, you can improve the base knowledge of your chat or whatever you are doing. And there is a bunch of different implementation of there that you can fine tune, or you can just go and customize using tools such as TensorFlow, Python, or JAX. But this is pretty much the tools that you will find in the internet, and you can start using. So this is pretty much what I wanted to show you today. For the next talk, I'm gonna focus more in the demos. Just trying to do some code in Python. Like talk about how to get it started. Like doing some kind of basic demos about how to use these APIs or how to use LangChain, all of this kind of stuff. But what I wanted with this session, which was like a pretty long, is provide you a review of the state of the art of this technology. and they show you all the opportunities that you guys have to start using in your daily life. Like it's just try to find the niche of to use that in your work and try to use it. Something that is pretty cool that something that I love was that right now Google mentioned that they have different. I think that I mentioned here. The foundation of for Google, they just released Palm 2 models, but these Palm 2 model are in different sizes. So Gecko, they say that Gecko gonna be able to run in the mobile device. So it's pretty nice that be able to run this in an offline mode, in a Flutter API, in a Flutter app, or in an Android API application, or this is gonna be nice. Gecko, Otter, Bison. So you have different alternatives, and basically the difference between them is the number of parameters, and the number of parameters generally means that it's a better architecture, but it doesn't mean all the time that going to perform better. And they mentioned about Gemini, which is something that kind of like a project that DeepMind and Google Brain are working on, but they mentioned that it's still in training. So there is a lot of stuff going on and coming in the future days. So yeah, it's just basically that. Please reach me out if you guys have any question. I'm gonna show here my. It's a lot of information, but I try to do my best to kind of synthesize all of these technologies, and I hope that you guys can have a better picture of what the future or what is coming for generative AI. This is my name, so you guys can go and check it out my website or my Twitter. And if you guys have any question about this or anything that we discussed today, I'm gonna be happy to address your questions.
Thanks for this really awesome overview, Henry. Like there's a few questions in the chat. So Randall was asking, how would hooking up an LLM with some quants AI work out if you wanted to trade with the stock market?
So can you repeat the question again?
How would using an LLM to watch news headlines and mix it with traditional quants AI work out if you wanted to use AI to get ahead of the stock market?
Well, so I think that I really love LangChain because LangChain you can something that you one of the tools that you have with these large language models to adapt the base knowledge to your application specifically is something that is using embeddings. So that means that you can somehow fine tune your model so that the model can have more context information related with your application. That this could be a stock market or this could be something else. So my recommendation is if you're a ChatGPT guy, go and check embeddings. If you are a more kind of Hugging Face guy, go and check Hugging Face agents. Or if you are kind of like someone that like to explore with different technologies, you can check LangChain. LangChain is basically like a way to. So you have this base knowledge that this large model has, but you can add more knowledge and somehow add context based on your application specifically, and the way how that works is using embeddings. Bar also have like an API to do to to work with embeddings. And how actually what is like I don't know how you guys check in ChatGPT or in Bar that you can define the context when you're gonna start the conversation. So you can say act as a data scientist or act as a nutritionist. So you basically are setting up the context. And when you start adding more and more information, basically what you are doing is you are providing more context to the model, so the model is able to figure it out what you mean. So then you can do the same thing using code, and you can integrate that in your application. And definitely go and check it out the embeddings. For instance, you can very quickly create an application based on BART or in ChatGPT that takes a PDF file, transform that PDF text into embeddings, and feed that into the large language model, and then the model will be able to provide answers based on that PDF that you give it to him. The same thing that you need to do.
Interesting. There are a couple other questions in the chat. Saba asks, do you consider source code generation versus human language text generation as multimodal?
This is a really good question. I think that it's multimodal, and especially because, well, it's a really tough one because, so natural language, when the model will produce natural language, they need to know the rules of the. Imagine that they're gonna do like a translation from English to Spanish or from English to. The model need to know about the structure of the language. So this is why the model is gonna, keep adding more and more different languages because the language has different structure. And this concept is pretty much the same in programming, right? You have like different programming languages, and every programming language have different uh, structure. You know what I mean? But I feel like they can be treated as a two different tasks. Like it's not the same. In fact, if you want to know more about that, so there are some unimodal architecture focused in just text code generation. Like recently, um, remember like tools like a ChatGPT and BART, they are multimodal, so that means that they can perform multiple tasks at the same time. But if your task is more specific to like something like like text generation or code generation, you can just go for like a unimodal uh, architecture. Like right now, if you guys go and check it out, the Hugging Face code generation tool, it's pretty good, and you guys can see also the architecture, the paper, and all of this stuff. StarChat Alpha, yeah, this is that one. So you just basically need to define. So I know that I have this monster out there that I can use to address my questions. So how I can adapt it for my context, right? You have different options. You can just go and use a multimodal model, or you can just go and use a unimodal uh, architecture. Unimodal is more specific. Multimodal is more kind of like is able to generate different tasks. So you just basically need to do like a trade off. What works better for you? You know.
And then there was another question again from Saba asking, can you elaborate more on model chaining that you covered near the end?
Yeah, model chaining is pretty good. Let me pretty quickly show. You know, chain. You forget the. Yeah, let me show you pretty quickly one example and check slant chain. So, sorry, let me. I'm just gonna try to share my screen. Okay, so I'm gonna please let me know if you see my screen. Launching. Yeah, basically how LangChain works, it's a framework to develop an application for a language model that uh, we not only call out language model, but we'll also, well, but the most important thing here is you have different large language models, and you can actually use different multimodal and unimodals models and chain them and provide results. So for instance here, I need to initialize OpenAI for to be able to work with ChatGPT. So I import from LangChain the chat models. There are different models. There are chat models, there are vision models, there are text embedding models. There are like, so you can just go ahead and use the model directly, or you can also um, create like a chain, like a chain. So then let me see if I can make an example where they combine multiple models. Sequential chain. So for instance here, they can actually, yeah, look at here. So I could have like a multiple tools and I can change them. So for instance, this gonna perform like a search, but this can also do something else. And then you can provide the prompt to your agent, and then based on the knowledge that you define in your chain or the tools that you add to them, so you're gonna get different results. So then could be your agent is gonna have multiple tools or multiple kind of models working together to generate the base knowledge of the agent, and then you can execute and run that command and you can get more information or more output according to the, imagine that it's kind of like adding skills to your agent. Your agent is a combination on one or multiple models working together, working like a chain to generate an output based on the prompt that you provide. So then you can keep adding more and more skills, and then you're gonna get more results. And you can also interact with what is gonna be the memory of your agent, callbacks, because the callbacks is another really important stuff, because when you have multiple models, so sometimes it's really difficult to kind of identify how those models are synchronizing and how working together. So that means you can have also callbacks. Okay, it's pretty much that. So you just basically define your agent. The agent just start kind of adding the skills. The skills could be like different large model working. So you create a chain and then you start prompting that agent. The prompting is basically the same stuff that you do in ChatGPT or BAR. You just write something, and you remember that you need to be very specific to guide the model to do to ask the model to do something for you.
So technically, the model input outputs are not chained, so it's not chained in this manner, but I can put together multiple skills, as you mentioned. Like, let's say I have a knowledge base which has text and maybe videos, and then one agent can generate text for the search, and the other one search example videos, which would be attached as example at the end of the response or something like that.
Yeah, it's pretty similar. I don't know, have you heard about the ChatGPT plugins? No? The ChatGPT plugin, you basically have you have the base knowledge, which is basically what the models know or have in his memory, right? So you can actually add more skills to that model, providing some plugins. So in LangChain they call tools, and so then basically you can define, so you can add more skill sets to your agent. So the agent is gonna have more tools to provide your output. So for instance, if you right now go to ChatGPT and just put, can you please solve this equation? He probably gonna struggle to try to solve that problem. But if you add the what is this plugin for do math? I think there is. Well, if you add this plugin to do math, so he gonna be able to solve that equation and provide you with the appropriate output. So it's kind of like imagine that adding more capacities to your model, but it's not like a chaining like the output from one and the output of other. It's kind of adding more like a reasoning, you know. And the same you can find also that in let me show you another pretty cool example that can give you a better idea. So if you go to the, I actually was planning to show you this transformer. So recently, can you guys see my screens? Yes. Yep. So you go to check the transformer API. They also have tools. So then, let me see if I can. Let me check if I can. Okay, so this is just the like a just a single agent, right? Like this can generate an image or like a boat, or this can generate audio or whatever you want. But the other thing here is tools. So these tools, so just basically this knowledge that the agent have access to solve or to answer your question. So for example, you can create a tool for document question answering, for text question answering, or for a speech to text. And you can ask, for instance, can you please check what is the weather today, but also transfer that to audio using the text to speech. So then he gonna provide you the output with all of this stuff. So you guys can, I'm gonna kind of share this link and see. You can see here how you can use uh, Hugging Face agents to do this kind of sophistications. Mm. I'm gonna share this in the chat. I hope this is clear.
So Henry, what are your thoughts on the hardware power requirements that these models have? And do you see those going down in the future? And do you see like smaller models being something of use?
I think that this is out there. Like right now, the companies are working really hard to come with a light implementation of this model, especially because it's not only like how much hardware they require, but also the negative impact that is generating to train all of these algorithms. So it's pretty good to see in the Google I/O announcements that they show up this new model that is called Gecko, which is based on PAL 2, and this is based on a like approach that is called distillation knowledge. Distillation knowledge, if you have like this huge model, but you can reduce somehow the complexity of your model by distillating the knowledge of the model until one point that you can actually run these models in uh, different hardwares or solutions. So I have seen people running Llama in Raspberry Pis. So if you really want to play around with this in like a low uh, resources hardware, you guys can go and check these kind of things. Let me think that I can. You guys can check in Google like Llama and Raspberry Pi. Yeah, let me check it pretty quick. Let me show you here pretty quickly. How to run a large language model on your Raspberry Pi. So yeah, Llama 7B. 7B is the number of parameters running in of 4 gigabytes Raspberry Pi. You don't expect it to run like a ChatGPT or BART in a Raspberry Pi, but you can play around with these fun models that is gonna work pretty good.
And speaking of distillation, can somebody like an individual developer distill down a model from, say, Hugging Face, or is it not that straightforward? How does, say, they want to just create a model for their own use case, say to generate, for instance, code for their own imaginary domain-specific language, for instance.
You can do that definitely in those other implementations that I show you, but ChatGPT 4 and Palm, all of these models, they are pretty close right now. The only way that you can actually fine tune them is by using, for instance, Google Cloud. You can go to Google Cloud and you can actually go to the model. Let me check very quickly here. So right now, if you go to Google Cloud, if you are so if I go to my console right now, so they have a bunch of different generation models here, foundation models. So I can actually go and check them, and I can actually fine tune them. Let's see if I put tags, extraction, embeddings, detection, classification. Yeah, but pretty much, but the only way that you have right now to fine tune this model is you can go to the Google Cloud Console and you can play around with this huge model. But if you really want to do some kind of more low-level customizations, you need to go and check these other open source or these kind of lightweight models like Llama or Alpaca or all of this kind of implementation that people in Stanford and in Berkeley have been working on, and they have somehow like make them free available for people to fine tune and customize for what. In fact, I think that Llama comes first. Like Stanford, based on like the Llama. Let's come from Meta, and then Meta. So someone didn't just come with Stanford just come with like a lightweight implementation, and then later on Alpaca came. So you can keep adding more customization and create new variants of the model.
So, Henry, are these models good for code generation or are they just better suited for natural language conversations?
They claim to be really good with code generation, and you guys can see that ChatGPT and Bard they were pretty good in chat generation, even in math. You are not aware about that, but for instance, PAL was trained in math, a lot of math formulas and equation and samples. So that means they should be able to do math too. So they are multimodal, and because that they should be able to be pretty good for code generation. Remember, just when you're gonna think about generative AI, just think: is my model, is my problem, or do I really need like a multimodal model, or I just need like a unimodal model? If I just gonna do for the code generation, you guys can check this model like Codex or all of this stuff in Hugging Face, and you guys can fine tune. Something that was really cool also in Google I/O that they mentioned is right now you can train Palm in your code base. That means that the model should be able to do prediction more kind of in the context of your uh, uh, in your code stuff. So you can, because remember that what you are doing is you are not actually training the model from scratch. You are fine tuning the model. Fine tuning means doing transfer learning. So that means that it's taking a model that is already training something to do something else, and you can fine tune the Palm code generation model into your code, and then it's gonna give you more prediction in this line.
And the other question was about recent announcement by Google. BR asks, what is Google Gemini? Um,
We don't really know. Yeah, in fact, they just really mentioned that we also have this model. This model keep training, but we don't really have any idea about what is that. So we are really excited about that announcement. Let's see if this probably come like a overperforms Palm too, and even like other alternative like ChatGPT. But my point is like I feel like for the next talk, if that happens, I'm gonna focus more in the ethics behind all of this stuff and the responsive part of how this model is. Something that is really cool that Google also is doing in this area, like a responsive generative AI, is they come with this something that they call metadata. So that means that all the PAL implementations, including bar, they're gonna generate water signed in the images and in the text that says generated by AI. So in that way, because there is gonna be the problem with that is that it's gonna generate a bunch of fake information. So right now they are also working in that area to improve the responsive or the appropriate way to adapt these all of technologies in the real life.
Yeah, there definitely need to be some guardrails around all this stuff. One last question from Sudhanshu was, how do you collaborate on solving real world problems with the AI community? And research seems very close. My answer to that was there's tons of open source projects, but love to get your answer.
Yeah, open source definitely. Open source is the foundation of probably pretty much all what we know about technology. So if you really want to generate impact, start just trying to see how you can contribute with an open source project. If you are kind of intimidated to kind of go and contribute with this huge project, you can start from something from the scratch. Like right now we are in the point that everyone wants to kind of democratize this technology. So you can create interface or application that use these APIs, low code solutions, web application, mobile application that people can use and generate content and all of these things.
Cool. I think that was the end of all questions. I think that's a wrap. And I'd like to thank Henry and everyone who's attending for this awesome and wholesome talk on generative AI. And Henry, I think you did a really awesome job on hitting all the points and giving a really good overview of the whole field. So thank you for that.
Thank you for inviting me, and I hope that you guys can get that information and start like applying all you guys know to create new tools that use all of these things. Like this is pretty awesome. And we need to show to the world the positive things that we can do with this technology. Not only discuss about like that AI gonna take our jobs.
Definitely. Right. Thank you, everyone, and that's a
Thank
wrap.
you guys. Have a good night.